Right. Yeah. While waiting for the other people to join, because that's the problem with these large conferences. It slices the audience into pieces. But the main guys always come first. So thank you for joining us. And we have put a great effort, to get some of the best industry speakers with, experience from the field, as well as beyond just pilots and research. It's stuff that has been done in the commercial world, as well as enabling technologies into large places like governments. So I'm very pleased to have one for you, some pioneers in their areas. I will not go into detail because I think time is very essential here to get the speakers in front of you quickly. So we have Dr. Hassnaa Moustafa from Intel. She had a red-eye flight last night, all the way from Intel base. And then Mahmoud Daneshmand is very famous within the IEEE community, has been helping out in all kind of disciplines and categories. And he has taken on big data as one of his main topics, so he'll share with us his views. Then all the way from Switzerland, we have Sebastien Ziegler. He's one of the rookies in the IoT world, as well as IPv6. So he's going to share with us some of his views on the IPv6 and IoT interoperability issues. And then from next door, Jim Pierre from Nist are doing some large-scale big data deployments. So I think the experience from the government is always very important. It signals the importance of the topic to the industry, which attracts, in this case, vendors, to supply very good products. So without going into detail, I would like to ask Hassnaa to join us. So I'll set up this for you. There you are.
Cool. Thank you. Thank you, Latif, for the introduction. So good morning, everybody, and thanks for the attendance. So this topic is mainly to talk about Industry 4.0 and what are the opportunities and pillars. We talk about IoT. IoT is a very big area, and from segment to segment, there are different challenges, different opportunities, and different technological pillars. Okay, that's, I'm not talking about any Intel products here, okay? So for Industry 4.0, if we look at it, what's Industry 4.0? There are a lot of discussions on that. We can describe in a nutshell, it's the growth and productivity in manufacturing industries. How to help the growth and productivity efficiency, we need some essential pillars. How IoT can help here. If we look at big data and analytics, it's one important pillar. Cloud evolution, we cannot constantly count on the cloud, which is the back-end cloud. That will be so expensive sometimes for real-timeness and information sensitivity. It cannot be a good solution. So we're talking about cloud evolution, migration to the edge. Autonomous systems, of course, is a very important pillar. And augmented reality. If we look at this picture, the first part of it shows how industry is today. Manufacturing is a kind of segregated environment. It's like sub-segments in these same segments, and without really interconnection and with less automation. If we look at the future and Industry 4.0, we can find that through machine-to-machine communication, we can have more efficient process. We can have also interconnection between the different segments if we have communication, reliable communication capabilities, real-time communication capabilities. Automation is an important point, of course. Robotics is now more and more into the picture. When speaking about robotics, it's not limited to automated pieces of the machines and the robot within a machine itself. No, but even mobile robots replacing humans. That's a very big trend. And people may be scared and say, if robots will take our jobs, what will we do? No, we will not lose our jobs. We have more and more valuable jobs. We need to be there for the system itself, running the system, for developing analytic algorithms, for monitoring. So this will open the door to new jobs for human, and the less boring, the boring part of the jobs, like iteration, like repetition in manufacturing, robots can do so. Yeah, good data. When we say good data, that's big data, sorry. I said good data. Big data is a good news because it's all about data. Everything is becoming data. So we can use this data for different purposes. This starts by first phase, which is the acquisition of data, which can start from the very tiny sensors to the very big equipment that can bring more data. It can be cameras, it can be depth cameras. And after that, what will we do with this data? If we have data, that means nothing. We need to do something. We need to use this data in an appropriate way. And here, analytics is a huge area. Specifically, if we talk about real-time analytics, that's a business by its own. There is a need for several APIs, standardized APIs is, of course, preferable. Several applications opens the door for more application development, more developers, which are new jobs. And after that, action. Analytics will give insights, and there is a need for an action after that. If we talk about manufacturing, industrial environment, there are a lot of actions to be taken, triggering, actuation, and in real time. That's an idea of the IoT value chain in general. Where is the money? Some people may think that the money comes from the billions of sensors, given that they are billions, or from the computers, or from the devices. Actually, that's not true, because the value-added services comes more from the applications enablement platforms, meaning that the software and the enablement platform is a big piece of the value-added services. From segment to segment, of course, it differs. Connectivity is an important piece. It represents about 20% of the value-added services until now today. But with 5G, with all the wireless solutions, with time-sensitive networks, we can see more. So this gives us like a hint, world is changing. Okay. If we look at cloud migration to the edge, right now, if we're following the happenings, there is mobile edge compute, there is the Open Fog Consortium, there is the cloudlet, there is a discussion of how to push the cloud to be closer to the information, closer to the data sources, move processing closer to the data. That's the more efficient way. I mean, it's not a researcher's view, it's not industrial view, it's like the market trend, and there are several predictions mentioning that, and several solutions being implemented to support cloud at the edge. So for manufacturing, for industrial IoT, for Industry 4.0, that's a very important pillar because we need real-timeness. There are information sensitivity sometimes in factories, there are sensitive information that cannot tolerate to go to the cloud, and even if it's a private cloud, the idea is to keep it local. So this can be, I mean, when we say edge compute or when we say open fog, the fog can start from the local space where the machineries are there. There can be like server or multiple servers working together as fog elements for processing, for compute, real-time processing and compute at the edge for actuation, for reacting fastly in a real-time fashion. The value also is in terms of cost. That's just like a study that has been done showing the difference in cost between a cloud-only solution and between an edge plus cloud solution. When I say edge plus cloud, or when this study says edge plus cloud, this means that we cannot omit the cloud completely. Cloud is always there, but how to interact with the cloud, how to move the processing closer to the data sources and interact with the cloud when needed, when necessary. So we see the savings in terms of dollars. It's about 36%. Edge plus cloud represents about 36% of the cost of a cloud-only solution. And data volume, of course, we are minimizing the network bottleneck. We are using the bandwidth in a more efficient manner. We don't need to keep bombarding the network resources that we're having until the cloud. This allows availability anywhere. If I have cloud at the edge, there is availability anywhere because I'm surrounded, or the sources of data are surrounded by servers or by machines which are capable of processing and storage, starting from the local premise to a regional area. There is real time and efficiency and saving in cost, of course. If we look at another pillar or two other pillars, autonomous systems and augmented reality. Autonomous systems we're speaking about autonomous systems since years and years and with different definitions. In this scope, autonomous systems are heavily implying software-defined systems, software-defined networks and software-defined systems. Virtualization, that's really what can constitute an autonomous system, and plus more other requirements. To give you just sample use cases on autonomous systems, which is matching or which corresponds to Industry 4.0, we have automated surveillance. Right now, for surveillance in a factory or a manufacturing area, it can be automated. How to do that? There is a big trend to use drones with cameras to do this kind of surveillance in an autonomous way and to control the drones remotely. Autonomous driving itself, the autonomous vehicle itself, as a vehicle, it's a huge component. There is a need for several autonomous systems inside it to be able to interact in a real-time fashion in a totally autonomous fashion and enabling remote control when needed also. And in a factory, we can have automated guided vehicles that can move to transport items in inventory or others, and automated but guided. One sitting on his desk can do that. Same thing as mobile diagnostics operation, a robot working in a manufacturing environment and can be diagnosed remotely and can be controlled remotely. And in augmented reality and virtual reality, that's also very important because it gives technicians a way to control more the systems, to be able to diagnose the system remotely even, or if it's in place, it will be in a better way. So what are the diverse and new requirements here? Compute and connectivity is very important. We're talking a lot about TCC, which is trusted and coordinated computing, how to have, and TCN, time-sensitive network, plus ultra-reliability in terms of connectivity. When we say ultra-reliability, 5G is elephant in the room in this story, but there are other connectivity solutions, of course. TSN is currently being there in the IEEE 802.1, but there are other ideas of how to make it over wireless. And TCC is how to keep like time coordination between the different components of the systems, mainly the CPU, the network, and the I/O. And there are several features even in current platforms which are being shipped by Intel or others, like Hammock Harbor, for example, which ensures that. Location technologies is another feature and should guarantee high accuracy, indoor as well as outdoor, but mostly indoors for manufacturing. And as I mentioned, robots, drone, and augmented reality, and depth cameras, of course, is important. And the real-time and remote control capabilities. That's necessarily, otherwise we will automate, but we will not have a control. Okay.
Thank you.
Okay, thank you.
Thank you very much. We'll be taking a question afterwards in the panel discussion. I would like to invite now Mahmoud. I think these should be yours. Please.
Thank you very much. Hi, everyone, and welcome to the Washington, D.C., and welcome to the GlobeCom, and welcome to the panel, industry panel on IoT, industrial deployment. I was thinking last night, and night before that, and night before that, from day one, which we do not know when is it, 10 million years ago, 10 million years ago, or whatever, the data was generated about all aspects of the life, of the world, about human being. Oceans were generating data. Human beings were generating data. Data was always generated. Only recently, we have capability, a lot of capabilities like sensors, like devices, like wearables, like this and this, to measure, again, not all this data, part of this data. You are not continuously measuring the level of the wave or the direction of the wave on the ocean. That ocean is always generating data. In fact, here you see Hudson River. We have 200 sensors in the Hudson River measuring certain things about the river, which can be used about the environment, et cetera, et cetera. So thinking about all of these, I came up with some end-to-end IoT and big data. From the left, you can see we have things domain for every vertical, for a smart city, for intelligent health, for intelligent, you name it. For every vertical or every application, we have devices. On the left, we have, things domain. We have then device domain. And you remember when we measure this data, we have to send it somewhere. So we have a network problem, like all the things that she was mentioning. You have to send it somewhere. And at that somewhere, we should extract knowledge from this data to learn about the world. Therefore, it comes the concept of analytics. And by the way, the real-time analytics is becoming more and more important, okay? I have a slide here. I wanted to quickly show it to you, which would apply to a number of us which are older generation. One of my students did that, is working on this project. So the patient, the older patient, which there are not patient, older people, there are 60, 70 million of them in the US, sitting on their table, watching the TV. The wearable is measuring me all the time. Wearable is reporting my blood pressure, my heartbeat, et cetera, all the time, sending it to certain systems, from certain systems to medical institution, from medical institution to insurance company, from insurance company to eventually to my doctor. And as I'm watching TV, my doctor shows up and says, "You forgot to take your blood pressure pill. Take it now." You see, the real time. So this is the important aspect, and she also indicated the real-time analytics of the data. So repetition of this slide is what Goldman Sachs put together about sensing the world, efficiently sensing the world, networking, sending the data somewhere, specialized, meaning for every vertical, and everywhere, everything. And that thing, and yesterday, a few days ago, Gartner, I believe, listed top 10 technologies for 2017 to 2018, and top IoT technologies was IoT security, IoT analytics, IoT process, IoT operations, IoT device, low power communications, even the streaming. So many skills and disciplines goes into end-to-end, from devices to analytics. Nobody knows all of it, so therefore, I know I'm focusing a little bit on the analytics aspect of it. How much data is generated? A lot. We were in information revolution of one when we were printing, then we were telephone, and finally today we are in the world of, as she also indicated, is IR5, which is 5G, which is IoT, which is SDN, generating lots of data. And therefore, the challenge is, one of the challenges is data analytics. In fact, I'm quoting from chairman of the IBM. She gave a talk on the Consumer Electronic show in Las Vegas this year, and her key sentence was, the challenge of IoT today is making sense of all data we are creating and capturing. The future of the Internet of Things is cognitive computing. The most, so far, the smartest machine in the world is human being. We have been always looking at the data, analyzing the data, making the decision, and fast decision, and the real-time decision. Anyway, so the cognitive really refers to that. So it will change, she says, it will change what we make, it will change how you operate, and IoT will change who you are. And at the same conference, the chairman of the Federal Trade Commission emphasized the issue of the privacy, data privacy. So this is the slide we put together, the relationship between Internet of Things to the left and big data to the right, because our focus is a little bit on the big data. So we monitor, we instrument, we monitor, we analyze, we decide, control, instrument, continuously doing that and improving on the analytics and making intelligent decision. And now putting this analytics into perspective, I'm just focusing on the analytics now. There are a number of important actions. The input is raw data for any area. We must collect this raw data. So the input is raw data. So the devices that measure the right thing, measure it correctly, the integrity, the data quality, all of this comes to picture. Then collection of this data means sending it somewhere through the network. Network must be reliable, must be safe, must be secure, must be reliable. We get the right data. It goes to, then we do cleaning the data, we do transform the data, we do the database, then comes the column of mining and analytics, and the last one is deployment and interpretation and making decisions. This is the end-to-end. If we go over it a little bit more detail, it is very much involved. For instance, only life cycle number one has a lot of these tricks of the performance, of the integrity, of the quality, so many aspects of only that data analytics part. And then therefore, I want to share this with you, the challenge. IoT leads to even bigger data and different data, not static data. I mean, it could be static, but it's useless to put it on the database and come back to it 2 months later and learn there was a tsunami last week in such and such a place, okay? So it is data streams and near real-time streams analytics. Think of anything, human being health, intelligent medicine, intelligent smart cities, smart grids, environment, connected vehicles. All of these means real time. In the mobility phone, we were doing it. In the telephony, we were doing it a long time ago. In the credit fraud, we were doing it a long time ago. Real time analytics, and that is the next sentence I want to share with you. I already did that. There was a team of people said, this problem requires close collaboration of a statistician, mathematician, computer scientist. It is a real multidisciplinary area to come up with the fast, real-time analytics of this data, which is being generated all the time. And then, okay, I think I already said that, you never step into the same stream twice. I think Heracles said that, and the nature of the analytics has changed, and she also indicated that, and the future, therefore, on one item are two things, analytics and computing. A lot of challenge in those areas. On the area of analytics, the focus is going to be on the human brain. You remember human brain was used for the artificial neural network? The future is understanding a human brain and how the human brain and eye interact with each other and do the real-time analytics. We always do the real-time analytics. And therefore, the future, I think, I'm not going to go over detail. You have to understand how the eye works, how the brain works, and that's why there is a brain initiative. Combining these two, you're coming up with a large we hope to come up with a large number of algorithms which does the real-time analytics and real-time decision-making. So that's as far as the analytics is concerned. For those of you who are PhD students or want to do research or whatever, or we are in the business, that is a very important area of the research, using the cognitive to do the analytics. And the other thing, of course, is, as she said it, yes, we were doing cloud computing, fine, but when it comes to real-time analytics, the fog and edge computing becomes extremely important, because you want it to be fast, you want it to be real, you want to be near to the edge, and there's no need to send it to the whole cloud. We can do that at the edge, make a decision at the edge. I have an example here about a smart city kind of application. Thank you very much.
Thank you, Mahmoud. So we're basically moving from big data to big IoT data, especially real-time computing with it, which is another area of progress in this world. So I would like to invite the next speaker. So we have the next level of understanding how IoT in interoperability.
Thank you, Latif. Good morning, everybody. I will try to give you different angle, complementary angle and perspective on industrial IoT from it's a place which is a kind of I would say in the fog between the technology and the market requirements for IoT. My name is Sebastien Ziegler. I chair the IoT Forum, and I'm also director of Mandat International, which is a foundation and research center working a lot on IoT. Let's try to start from the industrial IoT requirements, some of them. We will not address all the requirements, but there are clearly a certain number of key fundamental, essential requirements we need to address. First of all, the fact that, as it was mentioned this morning in the keynote speeches from Intel in the main room, as it has been introduced by many speakers, the IoT will be massive. It will be pervasive, and in many different applications, from hospitals to smart cities to a smart factory, we will have huge number of sensors, actuators, and data which will be transferred. So we need to address scalability. That's obvious. Another one, which is also important to take into account, we are moving from a silo and vertical or vertically organized structured market towards a more integrated and transversal market with technologies that will encompass different silos, different application domains, which means also that we will have more and more deployment which will be made and led and implemented and maintained by different stakeholders. The previous model where you used to have a company saying, we come and we will deliver the whole solution for your domain in energy efficiency or building a factory is probably certainly moving and shifting away towards something which will look more and more to resemble more and more to ecosystem, different players, different stakeholders, which means that you will have different technologies, different solutions that must be interoperable. We will have to address heterogeneity and interoperability. A third element, which is key, the fact that IoT used to be something at the edge of the needs and concern of the players, the stakeholders. It's becoming more and more central. IoT is controlling not only the energy, the electricity, the temperature, the security, access, can be a source of threats, cyber security threats. So we are becoming more and more dependent on IoT deployment. So there is a need to ensure that what we're deploying is reliable, trustable, and that leads to another issue is to ensure that what we are purchasing in terms of IoT solution is conform to a predetermined or defined set of requirements. So conformance will be an important issue. And if we take these three main set of requirements together, it highlights the needs and the importance to develop IoT standards that are open and that can enable the industry, the research community to converge and to deliver solutions that will match and fit with these requirements. So standards will be a key factor of success for the IoT market, in particular for industrial IoT. I will introduce and say a few words about a project which has been initiated in Europe through the H2020 research program, which is named Finterop. It's a project which brings together different stakeholders, industries, universities, academics, standardization organizations like HC, and which is working not only at the European level, but it has benefits from an advisory board which brings together partners from all over the world, including Consumer Electronics Association, HP, Cisco, Tokyo University, and others. The project is currently federating or bringing together 3 important IoT federation of IoT testbeds in Europe, Fed for Fire, IoT Lab, and One Lab, and gathers altogether about 32 testbeds on over 4,500 modes, which are made available to the project for performing tests and validation and research. And the core idea of this project is to develop a platform of online testing tools for IoT, to test interoperability, online, conformance, and performance. And when I mention performance, I refer to scalability, QoS, different parameters that may be relevant for the industry or for the developers and the researchers. One of the ideas behind it is to transform the way we currently handle, for instance, plug tests. For some of you who have taken part in plug tests, you know that it's a process which is very interesting, very rich in terms of human interactions, but with a certain number of trade-offs. The fact that you need to wait until a certain period of time to meet. You need to set aside or to have resources to attend the meeting, to travel. It will take you time, and more importantly, it will give a certain rigidity to the process. So you have to wait until a certain date in order to perform the next iteration of test or interrupt tests with your peers. The idea behind it is also to turn this process into a more flexible, cost-saving, and inclusive process, including research teams from small universities who may have talented researchers to take part in these processes, and to have a more, I would say, efficient process globally. Referring to interoperability tests, it's something that is probably obvious for some of you, maybe not for all of you. The main difference between interoperability tests is the fact that you are testing one implementation against another one to check if these 2 implementations are working together. And conformance is really the fact that you test and you check if your implementation is conform to a set of specifications, usually defined as a standard, as a RFC, or whatever requirement specification. Another idea behind the project is to try to bridge the gap between the research, the standardization cycle, and the industry and the market, and to enable to follow up the process from the standards development and the standardization phase to the market validation and standard conformance validation. The project is working more specifically with 6 SDOs, so with the IETF. We have the chance to have the chairman of the 6-ish working group at IETF, who is directly involved in the process. 1M2M, which is a large, most of you know the standards, which is one of the major emerging global standards for machine-to-machine communication. We are working very closely with worldwide, with W3C, with a focus on the Web of Things. HC, which is a member of the project. IPv6 ready logo. Latif mentioned a few minutes before the importance of IPv6, and I think it's a key factor of success to enable a globally interoperable and efficient and interoperable IoT deployment. We need to move and to align the technology towards common standards, global standards, and IPv6 is certainly a key enabler in this context. And then the ITU, which is also a member of the advisory board of the project, to see how we could leverage on this effort to make it available globally to the international community. There is an open call. I will not focus on that, but if you're interested to submit a project in the context of the project, it's possible to join the project through the open call. There are some restrictions in terms of geographic participation, but you can always, if you are not part of the eligible countries, you can try to find a partner in one of the eligible countries to peer and to work together. And the key idea behind it, and we hope it will have a positive impact on the industrial IoTs to accelerate standards and innovation development. I will now switch to maybe two other aspects, very briefly. One issue that we foresee as a key factor of success for the industrial IoT is the compliance with privacy and personal data protection. We have a very interesting evolution globally from different parts of the world. In the US, the Federal Trade Commission is very active on enforcing and securing privacy, personal data protection. The European Commission has adopted a new regulation, the General Data Protection Regulation, which is now, which has been adopted in April this year, and which will have a direct impact on the industry, and not only on European industries. I know that other countries like India, Latin American countries are starting to work on this topic. So there's a global concern, and it's not something which is just, I would say, nice to have requirements. It's really something which is key in terms of market adoption, market penetration. End user will probably not accept to have the data exposed to privacy breach. So if you want to have consumers, whether it is business or individual consumers, to adopt technology, you need to take into account the requirements and the concern regarding personal data protection and privacy. And it is also now a legal and financial risk for companies, because for companies that will not abide on respect those rules, there are very important consequences that may emerge. In the GDPR, for instance, in Europe, a company that would be breaching the personal data protection rules is exposed to up to 4% of its worldwide turnover as a fine. So you can lose, for a company like Google, over $1 billion, have a fine of over $1 billion for not respecting these rules. So it's something very serious that we have to take into account. In this context, there are quite a number of initiatives. One of them is Privacy Flag, which is a project which tries to combine the GDPR, ICT technologies, and crowdsourcing end-user involvement to monitor and to ensure that IoT deployment are conform and compliant with these obligations, in particular in European smart cities. Another approach which is led, related also to Privacy Flag, is Europe Privacy, which is certification schemes on personal data protection, which is combining the GDPR, ISO standards, and different models to try to provide a comprehensive model of certification for personal data protection. So that would be another challenge, I think, in the coming years for industrial IoT. I heard something very interesting before regarding the time deterministic networking. That's something that would be probably an important requirement, where we have very interesting developments at IETF in different venues in order to develop and to implement and propose new solutions to improve the reliability in terms of QoS, in terms of connectivity, including for mesh networks, including for modes who have to sleep and to save energy, but to ensure that to be reliable enough in order to ensure that these modes can transmit in almost real-time relevant and critical data to their addresses. Now, just a few words on two upcoming events that could be an opportunity also to discuss, and we invite you to take it into account. We will host in Geneva in June next year, from June 6 to 9, 2017, together with the ITU, the IoT Forum, and many other organizations, the IoT Week, which will address, as usual, the emerging technologies for IoT, but also we will have three very specific topics and tracks. One on IoT and sustainable development. We are working with the UN system and the ITU to identify how IoT technologies could contribute to achieve the 17th Sustainable Development Goals adopted by the UN. We'll have another track on IoT security and privacy. And again, that's a critical issue and challenge to be addressed. And finally, there is another track on IoT, finance market, and Industry 4.0, where we will directly focus and address IoT, industrial IoT. And together with the IoT Week, we have the chance to co-locate the Global IoT Summit, which is endorsed by IEEE and the Technical Subcommittee on IoT. And that could be an opportunity also to share and to discover some papers, scientific papers from different peers and colleagues. So thank you very much for your time and attention.
Thank you, Sebastien. It's very rare that you finish on time because you can speak for hours. Okay, so maybe we'll go to the Last but not least, speaker from
You're contributing to the GTN working group?
yours, Jim from Nist. We have a real case with us.
Hello, good to be here today. I'm Jim St. Pierre from Nist, National Institute of Standards and Technology, which is part of the, pardon me, U.S. Department of Commerce. We have a wide range of research. I'm in the Information Technology Laboratory. I was asked to come today and talk about some of our big data work, and we're focused more on measurement and standards. So what I was going to focus on today are really three aspects of that. One is a public working group we have that's open to everyone, that's open for participation, that I'll tell you more about in a minute. The other one is trying to work more towards the idea that, as the panelists have talked about, Internet of Things is generating tremendous amounts of data. How do we use that data, get knowledge out of that data? And one of the challenges we've seen is in having sufficient metadata to allow you to combine that data, to do joins on that data, to mesh that data in real time without having to spend lots of time going back to understand the data, have data registries to support that. And the other one is standards, a newer effort we have at Nist, looking at, again, we're a measurement and standards lab, so how do you measure things like data analytic tools? We have a long history of evaluating things like search engines, right? So we have our, if anyone's familiar with our text retrieval and evaluation conference, that gives challenge problems, find this type of information within this corpus of data. We're trying to take some of that approach, that evaluation approach, and challenge problems and use it for data analytics or data science evaluation program that we're running. And that's also starting to look at things like artificial intelligence and machine learning. So first, why the Big Data Public Working Group? It actually started back in 2013 through a cloud forum that we were holding, a cloud and big data forum, but it was mostly focused on cloud. And there was a real need identified there, and a lot of consensus around the need for better understanding of some of the key questions. What are the attributes of big data solutions? How is big data different than traditional data? And what does the differences imply for the technology and the infrastructure that we need to support it? So out of that effort that's what drove us to move forward and put together this public working group. And really the group is aimed at sort of a vendor-neutral, technology-agnostic, infrastructure that really lets a data scientist, the idea is to enable deployments, right? So to enable people to take, as we talked about, the interoperability, Sebastien and others talked about, to take different products, different tools on different compute platforms and not have the data scientists have to spend all their time figuring out how to get this to run optimally, but rather to be able to get in and use the algorithms they need, get help in finding the right algorithms, having them run on the optimal platform for that algorithm to run with that data, so that they can focus on getting the answers they need, not on dealing with all the infrastructure and the underlying technology. So within that, there's within the public working group, some of the efforts we have are a number of collaborations with ISO, IEC, through TC9, through MPEG is another one, and also I'll talk a little about intelligent transportation efforts. So within the public working group, they kind of broke things down into, first things first, let's talk about we have to have definitions, and then from definitions you want to define taxonomies. So, and this work is still going on, by the way, and I don't want to mention that the next workshop for the Big Data, the Nist Big Data Public Working Group is March 30th and 31st at Nist Gaithersburg, just north of here, about 40 minutes, in Gaithersburg, Maryland, March 30th and 31st, for anybody that might be interested in coming to that, participating. So really the five subgroups there define these different, the colored boxes here are the documents that they've been working on. They have a three-phase approach to that. And the first phase has already been released on these documents. The first phase really focused on what the components were of the reference architecture. The phase 2 will focus on the interfaces between those components. And then phase 3 will work to try to validate and do some testing of that architecture. So, and one of the things I wanted to highlight as well is that includes a consideration for security and privacy. We have, I'm not talking a lot about our security and privacy work here, but at Nist we do a lot of, in the Information Technology Lab, we do a lot of work in information technology, cybersecurity. We do have efforts specifically on IoT, but right now I'm going to focus on the big data, but if anybody's interested later, I could talk to you about that. What else here? Yeah, we'll go for that. Okay, so as far as reference architecture, what the group did was did a survey of existing architecture. So the participants in the public working group, you can see some of them here, a few of them here, that contributed what existing architectures they had. And the group then did an extensive analysis of that, and they found there was a lot of commonality in that. And using activity diagrams, functional diagrams, they found the commonalities and developed this higher level architecture. And again, phase one is just focused on those components. The focus of the workshop in March of 2017 will be on the first pass at trying to define the interfaces between these components to keep advancing this work forward. So here again, you see at the high level, right? You have the data scientists, you have data coming in from a variety of sensors, simulations, other sources, and then data consumers out the other side. And how do you define an architecture that allows you to plug and play these components and have standard interfaces, right? We found that having standard interfaces, as alluded to and discussed by some of the other panelists, is critical to being able to compose these systems quickly and not having to spend a lot of time on custom codes and things, but to have standard interfaces to configure the systems and then get to the real problems you're after. And a real successful approach we found there is defining use cases to help think through how the architecture could be applied and used. And these are some various different types of use cases that are actually captured in the use case document by the Big Data Public Working Group. One that we've done some work on the bottom row in the middle was some work that I'll talk about more in a few minutes of using different large data sets from census and agriculture, Department of Agriculture, to achieve a goal using the metadata approach that I just mentioned. Okay, so again, the big data standards activity. One of the things they found is that this was an analysis of the WG9 Big Data Standards activity. And what we're doing is taking the work that the Public Working Group is doing and taking it into the ISO-IC WG9. Wo Chang from Nist is the chair of that group. So he convenes that group, takes all contributions, as well, including the contributions from the Public Working Group into that effort. So here again, for those that might be interested in starting, you can see who the participants are by country, as well as the different, the overview of vocabulary was the first activity out the door, and then the reference architecture and the different subcomponents of that. Also, there's, of course, liaisons with many other subcommittees. There's many different activities that touch this, including the IEEE subcommittee on big data, ITUT, and the Industrial Internet Consortia. So this just shows some of the applications. We, in our information technology lab, we also have a statistical engineering division, and so we appreciate the importance of statistics in big data. So one of the ways our big data public working group is liaisoning with is with the ISO TC 69 applications for statistical methods, which are, of course, very, very important to pulling knowledge out of big data to find that needle in the haystack, to really make sense of diverse heterogeneous data sets. Another one that that the working group is liaison with is TC 204, Intelligent Transportation. Is several of the panelists talked about the emergency importance of drones and their different applications there, autonomous vehicles, and the importance of getting that right. Everything from understanding the data quality to the security of the data in motion. And so we are also liaisoning with them. Okay, so more about data interoperability. So this is the work that I was talking about, the metadata. Data.gov is an example of the federal government in the US trying to make government data available so that people can use it for innovative things. You know, the Weather Channel is a good example where NOAA's weather data is made available, and then there's a lot of tremendous uses that come out of that data. So there's lots and lots of government research data or other government data that could be used and developed into applications. So Data.gov does that. One of the challenges is it helps you find the data, but often you can't immediately use the data. It's not machine-to-machine usable. So how do we add metadata to that? And so that's one of the efforts. It's a research effort that's still ongoing to try to define an architecture, because finding data is fine, but it's not immediately usable unless you have enough metadata to tell you what, you know, say in the simplest case of a spreadsheet, right? You need to know what each column is, what are the units it was measured with, and you could get into a lot of more detail of how the definition of that data. So One example prototype we did with U.S. Department of Agriculture, NOAA, and the Census Department, they each had enormous data sets. And they were interested in one of the use cases, again, it really helps have a use case to try your architecture and to try out your approach, was a case in a flooding situation where USDA oversees the SNAP program, Supplemental Nutrition Assistance Program. It used to be called food stamps, so people that need assistance in getting food. And what the map would show, what they wanted to overlay in an emergency situation quickly would be where are the people that are using the food stamps, where are the retailers that accept those stamps, and also where is the floodwater. So then you can identify, you can say, well, look on the map, and you can say, well, there's a bunch of people here that need to get to food sources, but you can see the floodwaters have engulfed all of the retailers, and so they have no sources unless they drive many, many miles and they don't have transportation. So it can be used to provide quick resources, quick information and knowledge that could then be actionable to assist in an emergency situation like that. So again, that's ongoing. The architecture is, as you can see, sort of here. So the data.gov on the left, the data type registry on the right, and then the 3 types of data that I mentioned. This was a test case we did. So again, this is still a research effort. I think we've probably got 80% of the architecture, but then trying to work to continue and flesh out the rest of the architecture. But the idea being that the beauty of this would be if you had this in place, you could not only find data, but you could quickly grab that data and do mashups of it and actually use it in a much faster time than it would take to set up teams, to write code and write interfaces. This is just a interoperability, interagency technical advisory group that we have that works with us to help inform and provide requirements for that work that I just described. So last one I will touch on is the last topic is standards measurement for data science. I said this I think is very exciting because as we go forward with data analytics and big data, one of the issues is really how do we know how well, and we at Nist, we like to measure things and we like to standardize things because we think it really helps with innovation. Look back, of course, at the internet and the internet protocols, right? That base platform, that open standard platform provided for tremendous innovation and growth. So I think that happens throughout the information technology landscape. So lots of different solutions in data science, but what we need to, part of what we need to do is understand how to measure that. So some of the questions that were identified were, how do you measure things like knowledge representation through visualization? How do you know, how do we actually ascertain the knowledge representation there? The accuracy of the data, right? That's continually, how do you cleanse the data and so forth? That's, so these are many of the challenges. I won't go through all of them in the interest of time here. But then our program sort of looks at sort of 4 spokes, if you will, right? Sort of standards and best practices at the top there. And then working on the right side here towards better testing and benchmarking, test and evaluation applications and infrastructure. And then also evaluation challenges and services for big data and data science. And then, of course, out of that, you build a community of interest that's interested in working this and advancing the technology so that it helps form the core of folks that want to advance these areas. And one of the ones they're thinking about, the initial pilot they did, I have a slide on that in a minute, sorry. So again, applying measurement methods for data science and to help people understand their algorithms, their analytic tools, how well do they work, how well do they perform, where do they need to focus efforts. And then everything from cleaning and alignment to looking at various use cases to benchmarking runtime and resource usage and accuracy as a function of runtime. So initially what we did in 2015, a pre-pilot that was focused on some analyzing data analytics associated with traffic data, traffic video. We took that further and opened that up more in 2016. And then we're going to do an fully open, as this program continues in 2017, full-scale evaluation in multiple domains. And I know one that they're thinking about is thinking about potential for something along artificial intelligence algorithms. So measuring evaluating the performance of algorithms using a software library of components and how well they're able to put together a solution to a problem using a given library of components. So that is a quick summary of just a few of the things we're involved in, and I'd be happy to.
Thank you, Jim. I guess one consensus among the panelists is that basically data is the new oil. And sometimes it leaks, so some people even have lost their presidential thing. So you expect also some data wars in the future. I think some of the important issues that maybe we can address through some of your questions, and I have one until somebody thinks about a far better one than mine. So basically, it's not IoT that's important. It's the data that you generated and how you can exploit it. So you have the good things and the bad things out of this data. So the good things is the commercial world can make money out of it. So we know that from Google and Facebook and the likes. So when you go to a commercial conference, you cannot talk about privacy. You will be thrown out of the conference because what they want is to know exactly what people are doing and how they can sell them the stuff. When you go to research conferences and you talk about privacy, if you say that privacy is good, we should let people, offer their personal data and so on. And now with IoT, which is more invasive, they throw you out of the conference. So what is the best way of, sending the right message that IoT and the data generated out of it is good for some of the things, but still have to be protected in some other cases? So maybe we should give us some guidance in this area. Maybe you wanna start from
Sure, I'd be happy to. We actually have a program in privacy engineering at Nist that is really working on that problem. And so we actually like to talk about it, and we're happy to talk about privacy because there's tremendous benefits from this technology, tremendous from the Internet of Things, right? It's going to do great societal benefits, great for business. It's going to increase efficiencies and productivity. But of course, there are challenges with regard to cybersecurity, with regard to privacy. So what we're trying to do is develop some principles and an approach just similar to our risk management approach for cybersecurity, which is based on 3 primary principles. You've probably heard confidentiality, integrity, and availability, right? So you can think about cybersecurity under those 3 sort of principles. We have a document out. It's out in draft now. We do most of our documents, so most of our special publications, all of our special go out for comment periods, so everybody in the world can comment and give us feedback. We encourage that. So we're looking at privacy now, and really the idea is I think you need to design privacy in, right? So we really do. You hit on a really important point. We need to talk about it early, just like cybersecurity, and design it in. So the 3 principles we're initially thinking about for privacy are predictability, so understanding what's going to happen with my data when it's out there. Manageability, so how do I manage my data? How do I control, or what controls do I have to do regarding what happens with my data? And disassociability. So that's the idea that there's tremendous value in this data, right? And a lot of us, we do research where we have to get institutional review boards to review the data if it involves humans, right? Because there's tremendous value in the research of this data, but there's privacy concerns that are real and we have to be concerned with. So are there ways to use the data either in aggregate or other techniques you can use so that you can still use the data, but it's not associated with individuals that would affect their privacy? So research in those areas. So I think those are some thoughts about how we...
Would like to offer an opinion, Hassnaa?
Yeah, sure, thank you. Yeah, that's a critical problem, critical issue. I would add also, it's not a matter of privacy, it's only, of course, privacy is something big, but it's a trust of the data itself. How to ensure that the data coming from the users or from the sensors is trustworthy data. There might be several attacks where this big data that we're happy with it might not be trusted data, may be corrupted. So that's another problem which needs a lot of work, and it concerns mission critical applications specifically, time sensitive application. That's for trusting the data. Regarding privacy, of course, as mentioned by Sebastien, or by Jim, sorry, as mentioned by Jim, these are potential solutions, and also there is ICN, or information-centric network, which has been around since time. Yeah. And now there is a kind of association how ICN can help IoT. And privacy is one of the points where ICN can be promising, given that the data source is encrypted and the destination can be the one who can decrypt it. So that's a kind of work also and trend which is there, and hopefully it can help. Yeah.
I think Sebastien has also a lawyer degree, so maybe you want to share with us.
Thank you. I think something which is quite interesting, we are currently in a phase of convergence. Privacy, I would say, for instance, the US has been a region where we had some of the first privacy specialized NGOs, like APX and others. So there is a long tradition. In Europe, we had the same concept. People started reflecting on what is the impact of information, the information society on their private life, private data, but with a different angle. And the notion which emerged in Europe is not so much privacy, but personal data protection. It looks as a kind of minor change, but it's distinct, because there is the idea that even if a data is shared publicly, it still belongs to you with personal data protection. With the traditional approach of privacy, once the data is being disclosed, it's public. So you renounce to any link with this data. And what is very interesting that we have, and in other parts of the world, Latin America is developing a new model on personal data protection, which is quite interesting, which is distinct from the European approach and the American approach. And I think what is very interesting, we're in a period of time where we can start bringing together these different visions to try to develop a comprehensive and universal model of personal data protection, privacy model. And that's something we have to address in the coming year in order to avoid having a fragmented technology or fragmented market. Another element which is interesting, what you mentioned, there is in Europe this feeling from the European Commission that we need to have a notion of trusted IoT, not only trusted data. And there are quite a number of discussions, ongoing discussions at the European level to try to agree on what would be a trusted IoT. So it should include cybersecurity. It should be something that would guarantee that your IoT device is not easily hacked, as it was the case recently to launch a denial of service attack or this kind of cyber threats. It should respect personal data or privacy. It should also be reliable. So it means that you should be able to trust the device, that if it's a fire alarm, it will really launch and trigger the alarm if there is a fire. So it's paving the way to more complex and comprehensive concept and notion. So I was moving not only in terms of global geographic convergence, but also in terms of conceptual convergence, trying to combine elements which are quite distinct. Technical elements like cybersecurity or authentication strengths, cryptographic strengths, together with personal data protection, which is something which is more related to legal or societal norms or requirements, into something completely integrated and comprehensive. And that's quite challenging. I think we have in the coming years the opportunity to try to work together, because we need to find solutions which are not biased, which are not European solutions imposed globally or American or Asian solutions. We need to work together to try to find a common ground that would serve the global community.
Thank you for that optimistic view. Yes, Mahmoud, would like to donate some of your thoughts?
Okay, sure. I think my colleagues indicated several things, including data quality, data privacy, in fact, data governance. All of these are very challenging and important cases and issues. Of course, cyber security, cyber physical security, all of the above relate to the data. I'm going to talk about the privacy a little bit. We have and share with you our own experience in the world of telephony. If you want to manage your network well, network management, you should know the calls going from where to where at what time. And therefore, an important issue for us was to come up with a way of de-identification, meaning we were mapping him into a dot. There was a dot in the 2 billion dimensional space, which this dot at 9 a.m. from, I don't know, such and such a street in New York City, this dot got connected to that dot in San Francisco. And therefore, in the world of the visualization, we could see where we could do the network management, rerouting the calls accordingly, without knowing specifically that that's him, who called him, and what's the content of a conversation. That itself, that is, see, analytics is a very small part of the data, of the data thing. Preparation of the data, one of them is this one, like coming up with the programs and the way to de-identify the owner of the data. It takes a lot of efforts. And therefore, I think on every vertical, there is an open possibility and jobs to come up with the security of the data and privacy of data, so that there is a bridge here, there is a wall here, that on the other side, there is a data to be analyzed. At the same time, nobody's privacy is declared to the population.
It sounds like the dark net in the making. Any question from you? Yes, I think the room has a good sound quality. You don't need to have a mic, just maybe if you stand up and shout. Yes. If you could please shout louder.
Okay, I'll try to use my teacher voice.
Yes.
So I found that comment from Sebastien very interesting about the personal data protection thing. So in this world of IoT, where we've got so much personal data that's going to be exchanged over all sorts of infrastructure, do we see at all a move for changing the way we think about privacy traditionally, to as if the data is owned by the person who generates that data, and then go completely from that perspective, both in terms of making technological solutions as well as doing all the rights and so on and so forth. So right now you put your data up in Facebook, then it's now Facebook. But can we change that perspective? Do we see a move towards that?
Okay. So I hope you have heard the question.
Yep.
So basically moving away from the current model to kind of
I think it's a very, very important.
You want to quickly repeat the question?
The question is to see if we are moving from a traditional privacy approach towards something which is more based on the idea of data ownership, that the user, when you share your data, this data still belongs to you. And that's clearly I would say, one of the nuance or distinction between the European approach versus other approaches, that the European Commission has put a lot of emphasis on the fact that citizens' data belong to the citizens. So it's not a problem to make business out of it. The idea is not to prevent economic exploitation, but it has to be done with a prior informed consent from the end user, that the citizen is still the one who owns the data. And then he can decide to share it for free. So say, okay, I want to make it public, I don't care. Or to keep a certain level of control on that. And that changes the paradigm, the vision, the model. And that's one of the challenges we need to address in the future, is how to converge between different models, different conceptual models, into a globally acceptable model for the whole community.
Yeah, if I may make
Please.
a point here.
Yeah.
That really falls under the topic of data governance, and that's a very important topic. Let me go back to the example I gave at the beginning, that I'm sitting in front of TV and they're measuring, my blood pressure is being measured, okay? All right, first of all, I have to make a decision whether or not I want to share with my doctor and my insurance company whether or not I would like them to take a look at my blood pressure. That's item number one. I suppose this one I have in the US, we sign something when we go to the doctor that they can share the data with relevant people. So that's part one. I own the data, but I have to share it with the doctor to be able to make a decision. So the challenge in that example, for instance, which also falls in the data governance, is that the technology should make sure that this data goes through the Wi-Fi or whatever communication channel is to the hospital, and certain part of the hospital to see, and to the insurance company, and to the doctor, and to me. So that I cannot, for instance, or somebody cannot go into the network and in fact see my blood pressure other than my doctor. So that's yes, it's a very challenging problem. But there are two choices. Either I allow my doctor to see my blood pressure or not allow them. And that's the way it is. Sorry. Go ahead.
I have one small point here. Yeah, in addition to all that, there should be a kind of incentive. If I share my data, for example, in a shopping mall, I can get a coupon for something. So incentive is important also. An example, a simple example, if we want to download white papers, free white papers sometimes from the internet, we can have them for free, but we should log into a site, give our email address, our institution, our company. So here we give this data in a volunteer way, and we know that we will be bombarded by several emails after that, but the incentive is I'll get this white paper just in less than 1 minute and for free. So that's another point also.
So I just want to, yeah, I think that's a really important point. And the principles I was talking about, right? So we're a technical agency, Nist. We're not a policy agency. We're not lawyers. We have a few lawyers. We have to consult them to keep us out of trouble. But we're technical. So we're looking at a technical solution. And part of that is exactly what you got at. So like I said, the three high-level concepts that we need to work down to get to the specific, what are the controls you would do as an engineer? How would I design a system that has the characteristics you described, right? So predictability of can I predict where my data is going to go and understand where it's going to go. Manageability is the kind of thing you're talking about, so that it's who has control of the data, who has ability to grant access to the data, right? Because obviously there's certain situations you really want to grant access to your health data. If you're traveling and you become ill, you want those, they're not your local doctors, but you probably want them to have access to your data. So so our focus is on how do you provide tools for engineers to develop and design systems that are privacy enhancing, but can be used in a different legal frameworks and in different policy frameworks, but give them the technical tools to address the requirements for the given domain that they're operating in.
Maybe just to add a little bit to it. So you have the technology solutions, but also the policy solutions. And most probably, privacy is more policy than technology. Technology can only be done if the policy is done correctly, which is not very easy to do. Like when you mentioned privacy by design. So by design means it has to be done in the operating system. So you have to convince Microsoft and Google and Apple to design privacy in the operating systems. They are not going to accept because they make money out of that thing. So it will take a lot of time until policy really understands how this privacy can be done across the board. So some of the solutions proposed here, you can do them in niche things. And if you look at your, just your bag, you'll find a lot of loyalty cards. You have already given away your privacy without even knowing it. Huh? So against a little, discount or whatever, you're willing to give these things. So the approach maybe is, if you want to use mine, give me something for it. And probably that will be a good business model in the future, to sell your privacy data. But for the time being, I would say privacy is dead, whether you like it or not. You have to be a real expert not to diffuse your data. I talked to my son. He said, I never read emails. So go and talk to me with iMessage or what have you and so on. The new kids today, to them, privacy doesn't exist. They like to brag about what they're doing, where they're traveling, and so on and so forth. So it's a new generation which is taking over. So we should maybe also think about this new generation as well, huh? Because they have been, practically trained by the Facebooks and so on to think that way, which is not our case. We are oldies in that respect. So we are, clutching to the old style of some people think, I don't care, as long as I'm not doing any crime, I'm safe. Yes, you have a question? Yes, please.
Hey, my name is Zhen, coming from Comcast. I have a question about IoT deployment in industry. So I heard a lot about IoT future. What is the current status? Like, I know there's many, there's narrowbound IoT standards. There's also other standards going on even within the 3TPP. But there are two things kind of blocking
Sigfox,
or
LoRa.
all this, they already have some production available in market. So, like, what is the current status? Should we just wait until all the standards come in, or should we just go ahead with something available already? That's like, what do you see the future, the near future?
Yeah, that's a very frustrating question. Do you want, want to address this? This is like with anything new, you know, the big guys don't want to do it unless you see the business case. So the big guy, you know, like Comcast and the other guys, show me the money. And they don't see the money yet in IoT.
Maybe just to give a very short insight, I think we are in a transition phase. We are testing, we have a certain number of standards emerging, like LoRa, Sigfox, you mentioned them. We have 5G, which is expected to absorb part of the IoT communication market. So at a certain time, you will have to wonder if, at least in city environment, urban environments, you want to have 3 networks coexisting for Wi-Fi, for cellular networks, plus a LoRa or Sigfox network. You have other challenges, for instance, with LoRa in terms of network architecture. You're in a star network architecture, which raises a certain number of questions in terms of scalability or risk of bottlenecks if you are really increasing the number of modes which have to communicate with a central point of failure. But it's a very interesting technology on the other hand. So it's probably a period of transition where we will have a certain number of standards that will emerge, and probably at a certain time they will be due to economic reasons, economies of scales or rationality or rationalization of costs. We will converge towards probably 1 or 2 major standards for global, I would say, large-scale IoT communication. Then, at the edge, you need to address and to have other standards that are more optimized for, again, for instance, deterministic networking at the edge with 6TiSCH and others. So it's something which is evolving. I would say probably from a business perspective, I think LoRa and Sigfox are very interesting standards for the medium term, short and medium term. For the long term, there are quite a number of question marks. So it's maybe a wave, and we have to go through it and to maybe leverage on this kind of deployments. And probably there will be something more mature and more inclusive, comprehensive, which will come later.
Maybe Hassnaa?
Yeah, I would add also, we cannot have one standard. There will never be one standard for IoT. It's not like mobile networks or so. IoT is huge. There are several segments, and inside each segment there are sub-segments. So we cannot have one standard. The short term, as mentioned, there are some standards which are predicted because they are working today, because they are unlicensed. 5G is a dream and is very good, but it cannot happen everywhere. Not in every region, we cannot have ubiquitous 5G coverage. That also will not happen. So even with 5G, we need other coexisting standards. So the point is more on interoperability and thinking of application and analytics, which is a crucial part in IoT. The point is how to abstract all these connectivities and all these standards to the applications, to have APIs for developers, OCF, or Open Communication Foundation, or Open Connectivity Foundation, which is the OIC, previously the OIC standard, is working on that, is working on interoperability, but considering like a narrow range of standards, right, a narrow range of connectivity. But I assume something like that has a good potential. If we have standards for interoperability, that will be very helpful for the phase which we are passing, because it's exploratory.
So basically there are about 50 different organizations that are working on IoT, and they have different protocols. So, you know, from Zigbee, you know, you have all of these guys. They don't have yet IP-based stuff in order to interoperate. And even within themselves, they do use different signals. So the best effort is to get these guys to talk to each other, which is not very easy to get the various SDOs in the different markets, and there are many verticals. So if you take the car industry, wow, there are 1,000 people working on this one, but everyone is doing his own thing because there is, IPR issues and so on and so forth. So you're getting really into industry stuff. And you look at the various verticals, all of them they have their own associations, and they're not willing to share with the other guys. So one of the efforts is to get at least at the lower layer and IP layer to get kind of interoperability. And then the application layer will have to be open to them. So it's a very big task, but the potential is quite known and quite big. So everyone is going to try to grab a big portion of it, but that's part of the business. Yes? We have lost our ears with age, you know.
Coming back on privacy, and particular for the example of the health monitoring, if it's used in a positive way, it looks very promising, but I see two risks. Is if you share your health data with your health and your insurance company, what prevents the company to cancel your insurance if you detect that you have a concern? And what if you don't want to share this data because, I don't know what, it's your property, you don't want to share this data, the company say, if you don't share, I can do this service.
Okay. I could give you the view, and it may be interesting to hear the view from the US side, but from the European side, from the new General Data Protection Regulation, it's very clear. First of all, you have a certain number of principles. You have the notion of prior informed consent. It means that you cannot, a company or any data controller or data processor cannot use the data of somebody without his consent. So you need to have a form of consent. Then this consent must be proportionate. You cannot, according to the GDPR, you cannot make this kind of unfair pressure. So you have to be fair in the way you provide sliced consent or granular consent. So you should be able, you are the obligation to propose, to say maybe there will be a trade-off, but it has to be balanced and justified. Otherwise, you should be able to propose, it's the same for a website, for instance. If you go on a website, you are invited to use, to accept the cookie policies, but you should be able, in principle, to use the website without the cookies if you don't want to use the cookies. So that's part of the European approach, currently the European approach. And there is also this idea, as I mentioned before, that even if you share your data and you accept to share the data with your surgeon, you still have a certain number of rights on this data. It's not because you said, oh, I share this data with my physician that I've lost my data. You still have a fundamental right to access your personal data, whoever is holding your data, to rectify them and to erase them if you want. So you still have this control. And then there is an issue of balance. The idea is not to block the industry, but it's to find a right balance between citizens or individuals' rights and the need of the market and economy, but to try to find the right balance.
I mean,
but that's the European approach. Again, it may be different philosophy, which are not better or worse, but different philosophies may be developed in other parts of the world.
Because sharing data with the insurance is just to get the coverage authorized for an operation and so on, but they will not get, your disease and so on. So because in the US you have to get authorization beforehand. And we have that in Europe as well. So you have to get the authorization to get the operation done for whatever. For glasses and this and that, you have to get, at least in Luxembourg, that's the case. But they will never know what kind of disease somebody is getting. Okay, so it's just for the. I know what you mean, but that will not be the case because otherwise nobody's going to be insured anyway. So if they know that you are already sick, you will not get any insurance. So they will put you on probation and so on. That will be counterproductive. No? Yes, please.
Thank you for the presentation. I think there are many challenges which are very interesting. Mainly, you talk about the privacy of people. As you said, if the young people now don't have any, I don't know if they're not, if they don't care about the privacy.
No, they will pay price later.
Yeah, or it's just they want to use the service. You install any application on the iPhone. Indeed, they ask you whether you accept. If you want to use the application, you have to accept that the application will collect a certain number of information from your smartphone.
Yeah.
And if you don't accept, you cannot install the application. So I don't know if it is fair. But the main problem is really this policies and the knowledge, because now it's becoming so complex to understand what we can do with the application, especially with data analytics and so on. You may accept
Yeah, that's very normal at the beginning of any new technologies. We're naive, we just use them until we get hit. Then say, oh, that was the case. It happened to the internet. Internet became known only in 1988 when a bug hit it. And then IoT, basically with the DDS attack, which is a good thing. Because all of a sudden people are like, wow. So even a camera can be used as a surface of attack. So it gives an incentive for researchers to say, we should take that seriously. So basically these things are very good for researchers and for industry to take these things seriously. Because IoT, nobody's taking it seriously anyway. And to go back to his question, the ISPs don't have the knowledge to deploy IoT services. Not yet. They're still fighting to get connectivity solved. And how to send you somebody to install cameras at your place and this and that and so on. They are not yet there. There will be small shops that are going to do that until you get knowledge and integrator and so on and so forth. Then maybe ISPs can pick up and say, well, we are losing that kind of business.
Just a last remark. I find it, to say, of course, this is education, educating young people about this problem of privacy, but also from technical part of the technical point of view, you have to make it easier for them to understand. If you go to Facebook and start to configure your privacy, you actually don't know what is really happening. If they give you the tools, they're so complicated that to understand
But that's the purpose. That's the purpose.
And I think that's a very interesting point. And I would say there are two elements which may be, there is an evolution, there's a learning curve. And I would say the younger generation, and when I discussed with my daughter, she is fully aware of some of the privacy issues. It's not that she's focused on that, or I never told her, oh, be careful about the privacy, but she told me, oh no, I never use my real name. I will always use a fake pseudo, or no, I will never share this kind of pictures because I know that later. But it takes time. And as you said, I was probably a certain number of, or we may have a lost generation in the sense that a certain number of people may pay the price for that. Because today, when you are applying for a job position, the vast majority of human resource department, the first thing they're doing is checking your profile on social networks.
But if you're good, they
so if they see you being drunk or having done whatever, it will be a key factor in your hiring.
Sebastien, a very important question to finish this panel. So what is your view in the next 5 years? How will IoT and data will be foreseen? What kind of role it will play? So this, I know it's a tough question for 5 years because you can't even predict your lunch today. I'll start with you. So
what is the question? What will IoT data?
IoT and data, what kind of impact it will have in the next 5 years?
Oh, okay. I think it will have...
That was a simple question, yes.
Tremendous impact. I mean, I think it's only going to continue to grow. I think there's so much benefit we can get from these systems. And I think these other issues, privacy, I was going to say one of the things we have a research group, one of our groups looking at usability of different information technology. So what's the usability of privacy tools, right, and notifications, because most people just click on those. So I think it's going to have tremendous impact, and we'll start to see, we are already starting to see some of the negative impacts, and I believe, my personal opinion is that will drive behaviors of organizations, right, it's still not clear how different IoT applications will be adopted if people perceive negative aspects to it. I believe they will be. We will overcome these things, but we have some challenges to face technically in how do we provide systems that people can trust, that are trustworthy, right? And that they feel that their privacy is protected and that their autonomous vehicle is not going to crash into something. So I think there's going to be a tremendous amount of resources put into it, and there's so much benefit to be gained from it. So.
Thank you. Hassnaa?
Yeah, I echo what Jim mentioned. There is a tremendous benefit. There is a tremendous growth in economies, also new services, new demands. But we have to be cautious about the usage. That's something which we don't have an idea how to do it right now. It's we're focusing on the technology and driving it, but what's the side effects of that? I think there would be side effects. There would be like, it's not only the sensors which are connected, it's the billions of people on this earth who are like this close to each other. Okay.
I would say foresee two major challenges from a high-level perspective. One is to address and to optimize the way we move and we handle, process data, to transform data into information, information into knowledge. And that's one of the challenges. It's related also to mobile edge computing, to avoid overloading, overflooding the internet. So we need to find a way to better understand how we can distribute the analytics and the intelligence at the edge in order just for the model to be scalable. That's one element. And the other one, I think it's, as you just mentioned, we have a lot of question marks, and we need to bring together people with different perspectives. We need probably to have a more comprehensive, and one of the challenges for successful IoT technology will be to have a more comprehensive view, comprehensive approach, which means bringing together the technological expertise, the technical expertise, together with other dimensions, which can be in terms of end-user experience, in terms of legal requirements or whatever, but to have a more comprehensive approach, which leads us and which will lead probably IoT to focus more on multidisciplinary research teams, trying to bring together different expertises to try to build together something which is relevant and acceptable by the end user and by the market.
Thank you very much, Mahmoud.
Yeah, I'm sorry.
Yeah, sure. Oops.
I think the overall benefit to the human being far exceeds the harm. Start thinking. In 5 years, there might be a revolution on human health, on cancer, on intelligent medicine, on environment and prediction of the earthquake and tsunami, because the world is always talking to us, okay? There are right now, IoT sensors are gonna tell us tree number 11 in California is gonna tell us, I have enough water, give water to tree number 36. This is really happening. Versus these short-term things like, okay, through the Facebook or through my mobility phone or GPS, as you indicated, if I want to use GPS, then somebody knows that now I'm in a pizza shop in Hoboken. And therefore that somebody may send me a coupon, as you said. Okay, by the way, street number 12, you get 10%. Yeah, some privacy is going on, but if they can treat and prevent my Alzheimer or my whatever, it far exceeds that. That's the way I look at it. I think it's a great opportunity for the human being.
Yes, in my small view is, we have something like 50% of the world population connected to the internet, and the other 50 will take a lot of time, but most probably they will be connected through IoT devices, like health, or managing their crop, or selling their crop, so basically just to make a living, and they will be making a living out of IoT devices. So most probably that's the place where IoT will have a bigger impact on mankind. And you've been very kind and solid staying with us for this in this wonderful place. And I would like to thank the panelists for giving us some of these sneaks in the future. Thank you very much.
Thank you.